All right, I'm back continuing to solve these radical equations. This next one, we have two radicals and they're set equal to one another. I'm noticing that they both have an index of 3. So in that case, I'm able to raise each of the sides to the power of 3. The power of 3 and the root of 3 are going to cancel, and I'll be left with 7x minus 7 equals 3x minus 2. We have x's on both sides, so I know that some people were wondering what to do or not setting the one side equal to 0, but we pretty much want to get variables on one side and our numbers on the other when this is like a linear equation. We have 4x minus 7 equals negative 2. 4x equals, let's add 7, and we get 5, so x is equal to 5/4. And we can check that in the calculator if we needed to. Let's go to just the handheld. There we go. And we can put that in here. Oh goodness, that happens all the time. All right, let's see if I can make this work. Is it going to happen? No. All right, so we're going to plug 5/4 back in to this problem. So we're always going back to the original. So we're going to go to the third root of 7 times 5/4. You can also use the fraction button for that. Minus 7. And we're going to see what we get. So let's see. We get, a very weird number. I think that's my fault for not putting a decimal point in there. So let's try that again. There's my problem, and we'll put a little decimal point in there so I can get a decimal. So this is 1.2 when I finish that. And then if I go up and alter that again, I can go up, up, hit enter, and then I can just go in and I can delete what I need. So we're going to have 3 times the 5/4, and I'm going to get over to the side, minus 2, and enter. I did it again. Yeah, you ever say what's just not your day. There you go. And we get the same thing, so 1.2. So we know that that check works. So that was a check using the calculator. All right, here's our next problem. This should be x plus 1, where we have a radical on one side and not on the other. And if this was just a number, we'd be easy enough to just go ahead and square and square. But this isn't just a number, it's x plus 1. So we're not going to distribute to each of those. What we're going to have to do is we're going to have to FOIL, write it twice in FOIL. So this side of the problem is going to be easy. The square cancels out the little square root. And in here, we're going to FOIL. So when we FOIL, first, outers, inners, last, and we combine it all, we're going to get x squared plus 2x plus 1. Now what we want is we want this equal to 0. If I have a squared, a quadratic, I have to do some factoring. In order for me to factor, the problem has to be set equal to 0. So let's subtract 19 and add an x. I'm going to do that in one step. Get 0 over there. I have negative 18, 3x, and then an x squared. So now I'm going to factor because I want to know what values of x would make this 0. And I'm going to have an x, and it looks like a positive 6 and a minus 3 would work to give me a positive 3 to add to and a negative 18 to multiply to. So that just means I have negative 6 and 3 as my two possible solutions. All right, I have two possible solutions, but I don't know if both work, one works, or none. So let's do a check here on this side. So we have our check. We're going to check x equals negative 6. So negative 6 plus 1 equals the square root of 19 minus x. negative 5 equals the square root of, oh, I'm going to put negative 6 in here. So negative 6 would make it positive. And that would be 25. Well, negative 5 equals 5? Nope. So negative 6 doesn't work because those two things aren't equal. So if we check x equals 3, this might not work either. So I might have no solution, but I don't know until I've tried. Equals the square root of 19 minus 3. There we go. So 4 equals the square root of 16. 4 equals 4. Yay! So 3 does work. So we're going to take 3 and we're going to use that as our solution. The last thing that we're going to do is look at this problem here. Sort of similar, except we have a radical on one side and it's equal to 2 terms, but one of them happens to be a radical. Solving this algebraically by squaring each side would definitely be doable. We'd have a lot of steps to do that, but we're going to utilize the calculator. The calculator is unfortunately only going to give us the answer that works, only the one answer that's the solution, or maybe 2. Algebraically, we'd be able to find all the possible ones. So let's do the calculator with this one. So let's pull this up. We're going to go to graph, and we're going to go up into the first function, and we're going to put this into the first function for f, and we'll put this into the second function for f. So let's do square root of x. I can't see my x. There we go. X plus 9. We're going to hit enter. And there it is. And then we go back into tab and our second function opens up. 3 minus the square root of x. And we hit enter. And I'm looking for, it looks like they may touch there. I can't really tell. I can zoom in. But the best thing to do is just to go to menu, analyze the intersection, because the intersection is going to tell me what value of x makes this true. So we'll go to the lower bound on the left, and and it does intersect because it actually gives me an intersection point. So if we move this over, we can see that the intersection point is 0, excuse me, 0, 3. We talked about what piece we want of this. 0, 3 is a coordinate point. The x is 0 and the y is 3. So when we're going to answer this problem, the only x that works is when x is 0 in this problem. The other possible solution that we may have gotten if we had done it algebraically, we don't know. The calculator can only tell us what would work as a real number. So we're kind of left saying, all right, 0. If I don't trust my work or trust the calculator, I can go ahead and check it. So the square root of 0 plus 9, is that equal to 3 minus the square root of 0? Well, square root of 9, is that equal to 3? It is. So I know that it works. So the calculator gave me the exact answer. I can go ahead and check everything that I've done so far in the same method on the calculator. But I also think that we should know how to do it algebraically. So here is both methods.